I just had to fix our water heater for the second time. Now, this isn't my favorite topic to talk about. I don't love working on the water heater, but for the sake of this video, I wanted to take you guys through a step-by-step process of how I figured what the problem is and how to fix it. Now, when we bought this RV just about a year ago, the water heater that came with it did not work at all. This RV is 22 years old and the water heater is original, so that's not a huge shock if it was broken, but the unit that we have is called an Atwood. It's a 6-gallon propane and electric water heater, so it's supposed to work on a switch up at our panel, and there's a switch on the back that works on electric mode. Neither one of those switches worked, so honestly we didn't know, is it an issue with the unit? Is it an issue with the wiring? We don't know. The company has since been bought by Dometic, so Atwood, Dometic, same thing, but I think that all RV water heaters are similar in the way that they're configured. We're gonna start up here at the control panel to show you how this system is supposed to work. So this is the setup that we have. This is the control panel for the RV. You've got a slide out switch, the generator, some holding tank readings, and then this one says Atwood on it. There's basically one on-off toggle switch and then a light that's above it. But what is supposed to happen is that when you flip this switch, a light comes on for a second and then it'll turn off. And that indicates that the water heater turns on successfully. This, I guess, is supposed to control the propane side of the heater. And then there's a switch on the back of the water heater itself that does the electric side. Now, the first issue that we were dealing with this water heater is that when we flipped the switch, no light came on at all. We didn't hear any noises, no light came on. We really didn't know, is it the water heater? Is it the wiring? We couldn't figure out how to get this thing to work. So to get a sense of what your issue is, you really first have to understand what is the direction of flow of the electricity. And then you can work your way down the line, testing part by part to see where your issue is. Now, for the sake of this testing, we can start at this switch right here because this is going to be the communication device with your actual water heater. So depending on what happens when you flip this switch right here is going to determine where we have to check next. So when I flip the switch, I'm getting a red light, which means that this is truly being supplied with power. If you weren't getting a light to come on right here, which is what we had initially, you want to start by first working your way down to the breaker panel and check all of your fuses. So we're gonna start off down here. This is where our breaker box is. So on the left side, you have all your AC outlets, and then on the right, you have the 12-volt side. So the water heater works on the 12-volt side. So the first thing that you're gonna do is test each one of these fuses to make sure that they are working. It is definitely helpful if you have some sort of label to see which one it is, but just to be safe, let's check all of them. So to do that, you're gonna wanna get yourself a multimeter. This is the easier way to check for me. You can also pull each one of these fuses out and just do a visual inspection. You should see a wire running through, and if there's like a burn spot or it looks like it's not connected, then that's going to be your issue. So you want to turn it to this ohms setting. And basically all that this does is checks continuity. If there is power running through from the red to the black, then it's going to beep. So there's just going to be two little pins on each fuse. You can touch one probe to the bottom and one to the top, and then it should light up, give you a beep if it is connected, and that means you're good. If you're not getting any sound, then that means you probably need to replace your fuse, and that might be the issue. But since we are getting a light on ours, then we can make our way outside and start checking at the water heater itself. So the first thing that we're gonna do is come out here and open up this panel to expose the contents inside. Now, if you're not getting a light on the inside, you're gonna wanna stay inside and focus on the problem until you can get a light to that switch. But if you are getting a light, but just nothing's turning on, your problem is most likely in here. Okay, so since we identified that the switch inside isn't the problem, let me quick explain how the flow of electric works in here. So the power is gonna initially come in through this brown wire up here. It's gonna come in through the top, flow down here into this thermal fuse, and then it's gonna go behind here into this thermostat and come back out from this brown wire on the other side, and that leads us into this control board. The control board is basically then gonna send power out of this red wire out back here into this ECO, which is basically another type of thermostat. It's gonna do some checks and then send power through this orange wire, and that's gonna open the propane valve. So that's gonna actually allow the propane to flow. Simultaneously, when that's happening, it's also gonna communicate to this igniter here and create a spark. So basically the propane is gonna flow and then it's gonna try to ignite the propane with a spark. You'll definitely be able to hear both of those things. You can hear like a whooshing sound of the propane, and then you can hear the igniter starting to spark. And then what's gonna happen is once the controller senses that there has been a flame that's lit, it's gonna send a communication back out on this blue wire, and that's gonna go back up to your switch to let the switch know that it did indeed fire and it doesn't need to keep trying to ignite. So once you identify kind of how the electric's gonna flow throughout this, now we need our multimeter again to just check all the different parts to see, is the power still flowing? And if we have any issues, then that will help us identify what part is potentially going wrong. So we're gonna start off with this brown wire here. It is connected to this thermal fuse. You can easily just pull this wire off and check to see if you're getting 12 volts right here. You're only gonna get 12 volts if the switch inside is turned to the on position. So keep that in mind. If your switch is off, you should not be getting any power here. So we can check this easily by turning our voltage to DC mode. It's gonna have an AC and a DC mode, but we were checking for 12 volts. So you can just touch your positive probe to this brown connector, and then the negative can just touch anywhere onto metal, and you should be getting about 12 to 14 volts. Right now we're getting 13.5 volts. So we know that power is coming in here and the issue is not at the switch. The next thing that we can check here is this thermal fuse. So what we're gonna do to check this is actually pull this entire thing off. So this just has connections on both sides. The easiest to check to see if this is bad, one is to do a visual inspection. If it's burned, you'll probably see a burn mark through and the wire is not going to be connected from one side to the other. But the other check you can do is a continuity reading. So again, when the probes touch, my multimeter beeps. So you can touch one side to one side and then the other side. So we can tell that this thermal fuse is good, and that is not our problem either. In this case, this was actually our problem, and that is why this thermal fuse looks so darn new. I wish that I saved the other one, but basically when we touched both sides and checked for continuity, we were not getting any reading at all. So it wasn't recognizing that the wire was connected, meaning that it had a break in it somewhere. So what I did as a quick fix is you can bypass this thermal fuse and connect this brown wire right to the board here. Just bypassing the thermal fuse. You just want to keep in mind that this should only really be done in a pinch and should not be relied on, because this thermal fuse is here for a reason and is a safety precaution to make sure that the flame doesn't get out of control. So if you do use it this way, definitely monitor it. But this was a really quick fix for us just to get it working. So when I connect this onto here, everything should kick up and work. Now, this was the process that I went through to identify where our problem was with the water heater. But if that's not your problem, you can continue to just keep working your way along the line. It might seem complicated, but there's actually a lot of exposed metal cables in here. So a lot of places that you can check for either voltage or do a continuity check. Just keep working your way down the line until you find where your issue is. Eventually, at some point, you're gonna get something that's not connected or something that's getting a low voltage. Some of the common issues that I've seen going wrong with this is one, the thermal fuse for sure, and then the control board is another common failure point. Now, luckily, a water heater is not an essential appliance that you need to do day-to-day activities, but I mean, we kind of wanted hot water, so that was our fix. That's what we figured out, how to bypass it temporarily until we could order some thermal fuses and move forward with the more permanent solution. One tip I would say for sure when buying a thermal fuse is, we were in Albuquerque when this happened, and the only thing that we could see in our area was at Camping World. You could buy a thermal fuse for a Dometic Atwood for $20, but after doing a quick search on Amazon, we bought a 4-pack of thermal fuses for $10. So effectively a quarter of the price. Plus it's nice to have some extra spares laying around, because this does seem like a fairly common issue. So I would definitely recommend you pick some up if you don't have any already. That's going to be my quick tip for the day to save a few dollars on your thermal fuse. But that's going to do it for this video. Please let me know if this made sense, if I put it into basic enough terms, or if I got anything wrong, because I definitely don't claim to be an expert in electricity. This is just what worked for our situation, and this is kind of what I experienced through the process. So far, we've only had issues at the switch itself and at the thermal fuse, but hopefully I explained well enough how to diagnose problems for yourself if you have an issue with one of those things or anything else that has to do with your water heater.